Good morning, everyone. Let me begin with a question. Have you ever stood near a waterfall and felt its tremendous force? Imagine if we could capture that energy and turn it into electricity to light up entire cities. That is exactly what hydroelectricity is all about. Water stored in a dam has what we call potential energy because of its height. As it falls, this gets converted into kinetic energy and then into mechanical work by the turbines. The greater the height, which we call the head, denoted by HHH, the more energy we can extract. So nature's water cycle, through rainfall and rivers, constantly recharges this renewable source of power. Now, let's walk through the layout of a hydroelectric power plant. Picture a large dam holding back millions of liters of water. From here, water is guided through massive pipes called penstocks. The high-speed jet of water strikes the blades of turbines, causing them to rotate. Attached to these turbines are generators. As the turbine spins, the generator converts this mechanical energy into electrical energy. Finally, this electricity is transmitted through switchyards into our homes and industries. So the energy chain is simple: reservoir, penstock, turbine, generator, transmission lines. Let's break down the physics. The potential energy of water at height h is given by P is equal to mg, h where m is the mass in kilograms, g is acceleration due to gravity, and h is height in meters. When water flows down, this potential energy turns into kinetic energy. K is equal to half a meter. V superscript to the turbine blades convert this kinetic energy into mechanical rotation, which the generator then turns into electrical power. The actual power output can be calculated using the equation P is equal to eta rho GQ H, where eta is the efficiency factor, rho is the density of water, Q is the volume flow rate, and H is the head. So, the larger the flow and height, the greater the electricity generated. Why do we love hydroelectricity so much? Firstly, it's a clean and renewable energy source, no smoke, no greenhouse gases. Secondly, dams provide multiple benefits: flood control, irrigation for crops, and even recreational lakes. Once built, hydro plants have very low running costs and can quickly adjust their output to meet electricity demand. Most importantly, their efficiency is among the highest of all energy sources. Using the formula, efficiency equals output power divided by input power times 100. Many hydropower plants achieve more than 90% efficiency. Of course, no system is perfect. Building large dams requires huge investments and often means submerging fertile land, forests, and even displacing communities. Over time, sediments accumulate in reservoirs, reducing their capacity. There are also ecological consequences. Fish migration gets disturbed, river ecosystems are altered, and natural habitats may be destroyed. And importantly, we can't build hydropower plants just anywhere. We need specific terrain with high rainfall and river flow. Let's apply the formula to a real example. Suppose water flows through a dam at a rate of 50 cubic meters per second with a head height of 40 meters, and the efficiency of the system is 80%. We use the equation P is equal to eta rho GQ, 8 substituting values. P is equal to 0.8 times 1000 times 9.8 times 50 times 40. This gives us 15.68 times 10 W, which is about 15.7 megawatts. That's enough electricity to power a medium-sized town. This example shows why dams are such powerful energy sources. So, to wrap up, hydroelectricity is about harnessing the gravitational potential of water. The energy conversion follows this chain: gravitational to kinetic, kinetic to mechanical, and finally mechanical to electrical. It's renewable, clean, and highly efficient, but must be balanced against environmental and social impacts. Hydropower remains one of the oldest and most reliable renewable energy technologies known to humanity. I hope this gives you a clear picture of how water, falling from a height, is transformed into the electricity that powers your light bulbs. See you in our next session, where we'll dive into another fascinating energy source.